Okay, chapter 7-2. On Friday, what I asked you guys to do was Math Excel, and you guys did very well on that. You guys had activity period to finish that, and you guys, I think that everybody can finish it. Okay, this is why I'm going to take class time today to go over these 3 hard problems that are on that worksheet. On 7-2, there were 3 very difficult problems that are concepts that, whenever I say very difficult, I actually mean they are truly, truly difficult concepts for you to grasp and understand. Okay, I'm talking more like a pre-calc level. These problems would be done in a different way in a pre-calc class. Does that make sense? Okay, but because they're put in the section, we need to approach them the way the section wants us to. So the very first thing that I want you guys to do, I'm going to be teaching you guys. And if you want, you can follow along in your graphing calculator. If you don't want to follow along in your graphing calculator and you just would rather sit and listen to me, that is certainly your choice, but understand that you're going to have to repeat this yourself here in a little bit too, okay? So with that said, number 13. A cake is 190 degrees Fahrenheit when you remove it from the oven. You must let it cool to 75 degrees Fahrenheit before you can frost it. The table at the right shows the temperature readings for the cake. Given a room temperature of 68 degrees Fahrenheit, what is an exponential model for this data? Now, how would I go about doing this? In order for me to actually calculate an exponential function here, what I need to do is find a regression model. Okay? Regression model was back in the day we did regression models whenever we did linear. Okay? Remember linear models, we did a trend line and we estimated it out into the future. So that's what we're going to do here. So what you're going to do is you're going to come over here to your graphing calculator and you're going to create a new document. That new document is going to be lists and spreadsheets. The reason why it's going to be lists and spreadsheets is because you actually want to put that data into a list and spreadsheets document so that you can then put it into a calculator. Do we understand that? Now, A, we're going to label that to be T for time. And then we're going to come down here, we're going to enter in the information they gave us. It goes 0, 5, 10, 15, 20, 25. Sorry, there's 25. Just to 20. Okay? And if I hit Control-7, that puts me at the top of my data. And then I'm going to go arrow all the way over here to the B column. And in the B column, I'm now going to go ahead and put in the other information they have there. And that information is going to be the temperature that it takes, that is when it cools, right? After 0 minutes, it is 190 degrees because that's what it's coming out of the oven. After 5 minutes, 149 degrees. How much you're taking. So I'm going to type in here temp. And it's 190 degrees at 0 minutes. At 5 minutes, it's 49 degrees. At 10 minutes, it's 122 degrees. And at 15 minutes, it's 104 degrees. And then at 20 minutes, it is 92 degrees. And I'm going to hit enter. Now, that's our information. Now, this is not how you do this problem, but I want you guys to see something. So I'm going to add another page. And I'm going to add a calculator page. In that calculator page, I'm going to estimate my regression model using that information that they gave us, okay? So I'm going to hit Menu, Statistics, Stat Calculations, and then within this, where do you think I want to have? What do you think I want to use?
Exponential regression.
Exponential regression is exactly what I'm looking for. So in my exponential regression, I'm going to put in my X list, in other words, what values do I want to use in my X column? Well, in my X column, I'm going to use my time because that's what X represents. In my Y column, I'm going to use my temperature. And I'm going to go ahead and have this stored in my F1 function. And I'm going to hit OK. Well, this is what I get is my lovely exponential model. Okay, but I want to see it. So I'm going to add a new page, and I'm going to go to my graphs page. See how it automatically goes to F2? Why does it automatically go to F2? Because there's already a function in F1, and if I arrow up and hit enter, I can now see that. Now the problem is I can't see my function. So what I'm going to do is I'm actually going to graph my scatter plot information. So I'm going to go to Menu, Graph Type, and Scatter Plot. You don't have to go through all of these steps, but I want to see my data along with the lovely little function that I just created.
Why couldn't you see it?
Because it's out of the range. Think about it this way. At 0 minutes, what is my temperature? 190 degrees, how much it is, right? That means that's my y-intercept. In other words, At 0, I have a point at 190 degrees. Do we understand that? So that's why it's out of my view window, because it's not within the 6.5 to 6.5 there. So I'm going to go ahead and let this be T for time. Arrow down, I'm going to let this be my temp. And I'm going to press enter, but I still can't see it. So if I hit menu and window zoom and then do zoom data, there I can see my information and my lovely little points about new problems, correct? Okay, well I have a problem with this. And my problem is this. If you look at this function, what is the typical asymptote for any exponential function out there? What is the typical asymptote? Asymptote being the point where the line where it never crosses, okay? Where we have our graph and it never crosses that line. So where is it typically? Well, let's think about that for 1 minute. The x-axis, right? So the x-axis is my asymptote. Okay, but if it's my asymptote, the equation of that is going to be y is equal to 0 because it's a horizontal line at y equals 0. Now let's think about that for a minute. That means it's 0 degrees, right? Well, if you were at 0 degrees Fahrenheit, how cold is that?
Too cold.
Why do you say too cold?
Freezing temperature.
Well, what's freezing temperature? 32 degrees is freezing temperature, right? Do we all understand this? So if 0 degrees is freezing temperature, here's what I want to do. I want to go back to this. And if I pull this thing up, menu, window zoom, window setting, I want, see how my Y minimum is at 83 degrees? I want to put that thing to be 0. Well, what's going on with that? How many minutes is it going to take for it to be 0 degrees?
A lot.
A lot. Well, the scale right here is going from -1 to 22 minutes. Okay? So at 22 minutes, I want to think about this a minute.
22 minutes only went down 100 degrees.
We went down 100 degrees. Huh?
It would take a really long time for it to go to 0 degrees if the room temperature is 68.
Yeah.
Oh my goodness, thank you. Good job.
That'd take a really
It's going to take a really long time. So what this is saying is this really a function at 0 degrees that we want to take these values at, the temperature values? Aren't these temperature values where we want them to be at room temperature, 68 degrees, is as low as we want this thing to go? Isn't that a true statement? Okay? So what we want to do is we don't want this thing to go below 68 degrees because if we do, 32 degrees is going to be freezing, and 0 degrees is going to be way.
It would never get to
It's never going to get to 0 because unless you put it in a freezer, right? Do we all understand that?
even then.
What's
So if
temperature
you
of
get-
freezer? They don't even
Like 31.
I'm not
Freezer
even.
goes down like -3, -10.
I'm sure there's certain types of freezers that you could get like that. Okay, what's the whole point of this problem? The whole point of this problem is for you to understand that this function actually has a translation, that they're moving this whole function up. So how do we go about doing this? So if I go back to this information with my data, what we need to do is we need to add another column here. And this column is going to be called my room temperature, RM. We're going to label that RM for room temperature. And you know what we're going to do? Is we're going to take, instead of being 0 being my room temperature, what are we taking our room temperature to be at now? 68 degrees. So don't we need to take every one of those temperatures of 90, 190, 149, 122, and don't we need to take 68 degrees off of them? Why would I want to take 68 degrees off of them? Because we're moving up the asymptote, correct? We're moving up the base level of where this thing is going to be cooled completely. Do we understand that? So what we're going to do is we're going to set an equal sign here. And that equal sign is going to be equal to my temperatures minus 68 degrees. And why am I taking minus 68 degrees? What's the significance of 68 degrees here? It's room temperature. And when I press enter, check it out. It automatically does it for me. Right? It automatically does it for me. Okay? So now, with that said, if I come back over here to my calculator page, is this equation going to be accurate for me anymore? No, because I need to use different data here. So what I need to now do is I need to hit Menu, Stats, Stat Calculation, and back to Exponential Regression. And what am I going to use for my X list? I'm still going to use my time, right? 0 represented 0 minutes, right? And what am I going to use my Y list? The room temperature list. And I'm going to save that in F2 because F1 is already taken. Now this is going to be my new equation here. Now how am I going to get to my new equation? So I go back over here, and I'm going to hit Tab, and right now I'm on my scatter plot. So if I hit my T for time, and then I hit RM for room, can I see my data for that? Do you see that data? It gives me new points, okay? Now, if I go ahead and I graph that, and I hit Menu, Graph Type, and Function, I arrow up to F2, I can write that function down, and I can hit Enter. So this is actually going to be the equation that you're going to get, but is it really? Because what did we do to every one of those temperatures? So if we subtracted 68 off of that number, what we need to do is have the equation reflect that by doing what? I need to go ahead and use this equation, which is 122 times 0.0922. To the x, and then I need to add to this thing 68. Why am I adding 68 to it? Because if I add 4 to it, it moves the graph up 4 units. If I subtract 4, it moves the graph down 4 units. And what I want to do is I want to move this whole graph up to 68 units, don't I? So when I do that and press enter, do you see it looks very similar to my original graph right here? Doesn't it look very similar to that graph? Okay, with the original information. And what we did is we actually just took that function and we shifted it up 68 degrees so that we could actually see that it is going to level out and it's never going to touch it. Great.
If every thing was subtracted 68, why does the direction of the graph change?
Why does it become decay? Or should it be growth? Is that what you're
Well, the
thinking?
lines aren't exactly the same picture.
The green one ain't the same as the blue or the red one as far as slope and whatnot.
Okay, it's not going to be because we're changing the data. The blue scatter plot here, we changed that data to reflect a 68 degrees room temperature instead of 0 degrees. Okay? So that data automatically has to change along with it. The minutes is going to be the same, and it's going off the old temperature. That's why these temperatures are so very, 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 very close. Okay? Now the question that it asks you, and the answer that you're going to put in here is going to be y is equal to 122 times 0.922x plus 68. And the reason why it's plus 68 is because we had to move that asymptote because it could never cross the y equals 68 range. We understand that equation, because that is what room temperature is. All right? And then how long must the cake cool before it before you can frost it? Well, it says that it has to be at room temperature. So I want to know how many minutes it's going to take for it to get to what degrees? 68. So how do I determine that? Well, if I come back over here to my graph, and I hit Control T for my table, do I want to look at my F1, my F2, or my F3? I want to look at my F3 because my F3 is the function that is making it being translated up to 68 units to have changed my y asymptote. Okay? So how many minutes is it going to take for it to cool down to 68 degrees? Look at that. You need to take that y column and you need to look until it gets to 68 degrees. How long is it going to take? Actually, what was it? It was You must let it cool to 75 degrees before you can frost it. So I don't want it to be room temperature, I want it to be 75 degrees. So where's it going to be 75 degrees? Where will it be 75 degrees?
Which one do you think? The first one?
Well, which one do you take? It's going to be roundabout in between 34 to 35 minutes. I'm going to say it's going to take about 35 minutes for this cake to cool before I can actually frost it. So when it's coming out of the oven at 190 degrees, it's going to take 35 minutes for it to cool before I can actually frost it. So this is going to be 35 minutes. Okay?
What was the first, second column? The other, the page just right before that. So you just exited with, yeah, what's the second column?
Oh, this column right here is my F2 column. That is going to be my function that was not translated. But I didn't move up 68 units. Okay? Now, do we all understand why I'm talking to you about this problem today? Because you had to get a lot of information out there. You had to understand that 0 degrees is way cooler than what 68 degrees is, and the whole relationship between that. True statement? Okay, well that brings us to the next concept here, problem 21. Now I briefly talked about, I think I talked about 22 in class with you guys the other day. Did I talk about 22? Now, since isotope HG197 is used in kidney scans, in other words, what does that mean? They're like chemical dyes they inject and use so they can light up your whole body whenever you're in a scan. That's what that isotope is. Do we all understand that? Yes. They inject you with a dye. Whenever they inject you with a dye, and they put you through a CAT scan, that dye lights up, and you can actually see what's going on in your body wherever you're doing that scan. Do we understand that? Okay? So, yes, it's just some generic number, but you need to understand what that actually means. It's used in kidney scans. It has a half-life of 64.128 hours. What in the world does that mean?
Means for about 72 hours, you have glowy stuff.
In other words, the question that we're talking about is you have this glowy stuff in you, and it takes its half-life. In other words, from the minute they put you in it, however much dye they put in you, it's going to take half of it to disappear. It's going to take 64 hours. Do we understand that? Yay, nay. Make sense? Okay? After that time, half the isotope will have decayed. Write the exponential decay function for a 12 milligram sample. Find the amount remaining after 72 hours. Okay, now with that said, how do I go about doing this problem? What is the standard growth or decay model for exponentials? I love the little equation. Y is equal a b to the x, or in this case t, right? What does a represent? The initial amount. So what was the initial amount that they put into you? How many milligrams did they put into your vein? 12 milligrams. And they're saying that that has to be half of what's left over. So what's my percentage rate, my half-life, my percentage rate? 0.05. 0.50. Okay. Do we understand that? So 50% of that is the half-life, correct? And how many hours is it going to be in there? It's going to be in there. Would they want to know after 72 hours? But how long is it going to take for 50% of that to go away? It's half-life. 64.128. Now, all of that should equal how many milligrams?
12.
What? Who said 6? Why 6 months? Because it's the half-life of how many units did they put inside me. They put 12 milligrams. So half of that, half of 12 is going to be what? 6. So if I have this equation, and I graph that, not graph it, if I do this calculation up here on the right should equal the left, correct? So if I come over here and I actually type that in, I'm going to insert a new problem. If I do 12 times 0.5 raised to the 64.128, would that equal 6?
Yes.
Ooh, no, not just about. What is that? That's e to the negative 19. So what does e to the negative 19 mean? That's exponential. That's scientific notation, right? So that's actually a really, really, really small number, meaning there's 19 zeros or 18 zeros in front of the number 5. So it's very, very close to 0. So does that make sense? Do they equal each other? Which means your equation is wrong, right? So how do I make my equation right? Well, this is a dead giveaway to make you understand that you have to have a variable there. In other words, I need to know what that number is multiplied by the 64.128 that's going to give me the correct answer. Do we understand that? Okay, well, if I solve this thing, what do I do with the 6 and the 12? What do you think I should do at this point? If I'm solving this thing for x. If I would divide both sides by 12, I'm going to get 1/2 is equal to 0.5 raised to 64.128x. Now, do those look like they're more equal now? What would it take for those two sides to be equal? Okay, what's the relationship between 1/2 and 0.5? They're both half, right? So what you're telling me is I actually have half is equal to half raised to 64.128 times x. So what would it take for those two halves to be equal?
I did that thing.
What does the x have to be to make those two things equal?
I don't make one.
I did that and it says no there.
Because you can't put that in the calculator. What will it take? What's my exponent on this 1/2 side over here?
1.
1. So what would it take for 1/2 to the first to equal 1/2 to the 64.128x? Are the bases the same?
Yeah.
So if the bases are the same, what can we conclude about the exponents? They have to be the same. So if they have to be the same, then 1 is equal to 64.128x. Isn't that a true statement? If the bases are the same, then don't the exponents have to equal each other? So with that said, I divide this by 64.128. And I'm going to get x. If I come back over here and I take 1 divided by 64.128 and hit enter, what is that? That is what's happening every hour for your body. That's the rate at which that lovely little dye is going to be coming out of your body. Does that make sense? For every hour. Do we see that? Okay, so that's going to be 0.0155. So I actually have the equation y is equal to a, which is going to be 12, times 0.5, and then my time was going to be 0.0156x. Okay, do we all understand that? Now, why am I having x there? Because what does the x, and let's not even put that as x, let's put that as t. Because what does that t represent now? The time that it takes. I can estimate any hour that I want to, correct? And what are they asking me to estimate? They want to know what's going to happen in 72 hours. I'm going to plug in a 72 there. So if I come back over here, and I type in 12 times parenthesis 0.5 caret 0.0156 times 72. How much is left in my body? Repeat that. Milligrams. Use it in a sentence. What does this mean?
You do have 5.5 milligrams.
What? After 72 hours? Perfect. Do we all understand that? Yeah. Okay?
Do it just like.
So do we all understand this problem? Okay? Because you guys are going to have to duplicate this problem. I did 22 for you on Friday in class, correct? Or I did it a Thursday class or something like that. But let's do 22 again. And this time what I want you guys to do is I want you guys to set it up yourself. I want to see how you guys do. So I want to see if you guys can duplicate this problem by yourself without me doing it for you, so you can get it and understand how to do it. And making sure we're showing all of our work and we're not just writing down the answer.
Well, if I know you're gonna do that, pay attention.
Get out a sheet of paper and get busy. I'm gonna give you guys like 4 minutes to do this problem. Okay. Where? Okay, and how do I do this problem? The isotope SR85 is using bone scans that has a half-life of 64.9 days. Write the exponential decay function for an 8 milligram sample. So I have this lovely little amount here. Do I need to have just a t, or should I have an x times the t? I need to have an x times the t, correct? So now what's y going to be? Y is at 4. Half of 8, very good. And I'm going to actually put half times 8 here. 8 was my initial, and what's b? 0.5. And t? 64.9 times x. Now, what's half of 8? I did it. Sorry. 4 is equal to 8 times 0.5, 64.9x. Now, what do I know? What do I do? Divide by 8, so I have 1/2 is equal to 0.5 to the 64.9x. And what does this tell you? So 1 is equal to 64.9 because the variables, the exponents have to be the same because the bases are the same, right? So now x is going to be what?
0.
Very good. So there's my daily, or my daily rate, correct? So y is equal to 8 times 0.5, 0.0154 times t. There's my exponential function. Now how do I do the rest? 100. Because he wants to know after 100 days how much of the dye is left in your system. And what did you guys get? Use it in a sentence, please. In your system after your bone scan 100 days ago. Does anybody find that to be a little bit freaky?
Yeah.
To think that you go into the hospital to get a test run on yourself, okay? And there's some contrast that they put in you, and then after 100 days, you're still like that inside. Right?
I wonder if that's a little more radiation.
Now, obviously, I don't know how accurate that is. I really don't know. I don't know if they just threw that problem in there and if it's really not 100 days, if that's still in your system, or if it truly is accurate, because that's just a crazy concept.
What if you had to go to the hospital 3 months later, and then what they had to give you for that session?
I don't know. Wouldn't that be an interesting concept? And think about all of that you have to do.
I had to drink water constantly for 2 days.
So it'll flush. See, and I'm sure that there's all kinds of variables out there that kind of make this a little bit different, but for the mathematics behind it, trying to give you an exponential function so that you can see. But like she's saying, if you had to drink a whole bunch of water to flush your system out, I'm sure that's not going to be a true equation then later on.
When I wrecked last year, I had to go to the casting, they didn't tell me nothing about that. They wasn't complaining.
Well, did you have any dye injected into you?
I don't know.
When you have dye injected into you, you literally feel like you're going to pee your pants.
I did have that, it was really cold.
It's really cold, and then all of a sudden it hits your body, and it's like, all of a sudden you feel like a gush of warmth.
I think I did that, but it's kind of like water.
But that, you probably did get dye then.
Yeah, they said that it was okay.
Real world life. Did we like this problem a little bit better because you could see the real world application of it? 0.5 is the half-life. It has half the life, which means 50% of it.
Onto the other side of
We did, but that's how much was left. Like the initial amount was going to be 8 milligrams. Half of that is going to be 4, but the reason why I know it's half of it is because it said it has a 50%. Half-life. Half-life means 50% of it is now gone. Does that make sense? So to get 8 milligrams down to 4 milligrams, it would took 50% of it away. Does that make sense?
And so you just multiply those, right?
Yes.
What,
Okay.
what numbers do you want to do homework?
Okay, tonight's homework, I want you to do problem 22, 36, and 37. Now, 22 is a graphing calculator problem, so we're going to have to work on that tomorrow in class together. It's like I just did for you today. The problem's 36 and 37 on page 448. Page 448, problems 36 and 37. Okay?
36. What is this? The,
It's the same thing that you guys did here. Chapter 7-2, practice B. (36 and 37), and then in class, you're going to have to do problem number 22. Okay? So tomorrow, whenever you guys get in here, I want you to grab the calculator so that you guys can do that. Is there anybody who still needs to finish Math Excel?
there, you got a
Okay, excellent.
I don't know when